All right, thank you for joining me for chapter 8.3, the ellipse. So I'm going to read you the long definition, and then on the next page, we're going to dissect what this definition really is. So an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. These two fixed points are called foci, and are a line segment through the foci called the major axis intersects the ellipse at the vertices. The midpoint of the line segment joining the vertices is called the center. The line segment that intersects the center and joins the 2 points on the ellipse and is perpendicular to the major axis is called the minor axis. Okay, really confusing. So let's break this down into a picture. All right, so I've got 2 points called the foci, plural for focus, okay? And if I take a string here and I connect it to both of those and kind of stretch it out a little bit, and let's say I put my pen right here, and I swing that around, just like with a circle. If I swing that around, we get this elliptical shape, and I know that's really bad, but you kind of get the idea of what's happening. Okay, so in this ellipse, I've got these 2 points called the foci. Okay, and then I've got a line running through those 2 points and intersecting with the ellipse. Okay, that line is called the major axis. Okay, and the 2 points on the ellipse are called the vertices. That one and that one right there. Okay, those are called vertices. All right, and then the middle of that line is called the center, which is a really clever name. Okay, and then running down through the center, perpendicular to the major axis, is called the minor axis. You should know this, but the major axis is longer than the minor axis. If both of those lengths are the same, then you have a circle and not an ellipse. Now these 2 points right here on the minor axis, some people have a name for those, and some people don't. But for us, we're just going to call it the minor vertex, or they are minor vertices. All right, so now with this ellipse, we've got some important distances that we want to know. And we'll label those A, B, and C. Okay, A is the distance from center to vertice. Okay, so from the center out here to the vertex. Okay, B is the distance from center to minor vertex. Okay, so this was A, and from here to here, it's going to be B. And then the only other measurement that we really want is the distance from center to foci. So this distance right here is C. Okay. Now, there's one that we may want to know, but we already know it, and that's the distance from the foci to your minor vertex, this length right here. We already know that, and that's A. Okay. So this distance is the same as that distance right there. Well, I just created this right triangle right here. Okay, and we use Pythagorean theorem with right triangle, but in this case, we normally know what A and B are. Okay, so we're normally looking for C. So in this case, C squared is going to equal your A squared minus your B squared. Okay, remember the order of these. Your hypotenuse goes all by itself. So if I would write this the normal way, it would be B squared plus C squared equals A squared. But I kind of went ahead and solved it for C, which is what we're going to look for. Okay, so I have a handout on the website that you should probably print out, kind of like we did with 8.2. It's got some really good information on it. Let me go back here and talk about the general equation. We got x squared over a squared plus y squared over b squared equals 1. Or we got x squared over b squared plus y squared over a squared equals 1. Okay, so some important things to know about these two equations. They must equal 1. Okay, you got to have a 1 over there. We want a 1 up here with the x's and the y's for their coefficients. So the only numbers you should have should be a and b down here. If they're not, and that's an a squared there. If they're not, we got to get it in that form, and that's what I'm going to be teaching you. Okay, so if we look at this picture up here, we notice that A is bigger than B. Okay, the major axis is 2A, and the minor axis is 2B. So A has to be bigger than B. So in this case, we notice that A here is under the x. So that tells me that the longer direction is going to be in the x-axis. So my ellipse is going to be elongated in the x direction. Here, my A is with the y, telling me that it's going to be elongated in the y-axis direction. Okay, so that's kind of how we can tell which way the ellipse is oriented. Okay, and then here we've got eccentricity. Eccentricity is how circular or oblong the ellipse is. So we take E, which is equal to C over A. And that number has to be between 0 and 1. Okay, if it is closer to 0, it's going to be more circular. And if it is closer to 1, it's going to be more oblong or lengthened out. Okay. If we go back up here, let's kind of go into this a little bit. I have the foci up here, and let's say the foci down here. As those two draw closer to the center, okay, what happens? Well, as they draw closer and closer, they nearly become the center. Well, the foci and the center are the same thing. Then I just have my string out here as a radius. And then I get a perfect circle, okay? Well, just the opposite happens if I continue them out further. Okay, as I stretch them out further and further and further closer to this vertice, these sides have to come in, you know, and it gets stretched out longer and longer and longer. They'll never become these vertices. If the foci and the vertices become the same thing, you don't have an ellipse. You've got a line. there instead of anything. Okay. So this is part of the handout that's on the website that you might want to print out and kind of keep handy. Okay, so graph the ellipse given by x squared over 25 plus y squared over 9 equals 1. So we've got to equal to 1, okay? And my bigger number is under the x, so we're going to say x squared over a squared plus y squared over 9, or over b squared equals 1. That's the equation we want to use. So in this case, it's simple to see that a is 5, because 5 squared is 25. And that's going to go in the x direction. And b is going to be 3 in the y direction. Okay, just simply because that's the letters they're under. So when we go to graph that out, my center is at 0, 0. We'll talk about later what happens when it's not. We'll go left 5. We'll go right 5. Okay, we'll go up 3. And we'll go down 3. All right. And we will draw our ellipse connecting those 4 points. Okay? And that's the graph. Now there's one other point that we may want to know, and that's the foci. Okay, so we need to find c. So c squared equals your a squared minus b squared. So a squared is 25 minus 9. So c squared equals, what is that, 16. So c is plus minus 4. So that means you're going to go minus 4 and plus 4, and there's your foci. Meaning if I take any point here and here, and take this distance plus this distance, I actually get the major axis. How long that is. Okay. All right, let's go on to the next one. So graph the ellipse 16x squared plus y squared equals 16. Okay, the problem with this one is this 16 right here. That has to be 1. So in order to make that 16 a 1, we're just going to simply divide it by 16. Well, if I divide that by 16, every term gets divided by 16. So then I've got x squared over 1 plus y squared over 16 equals 1. All right, so this 16 is larger on the y, so then we can say that a is 4 on the y. We're just taking the square root of that. And b is 1 on x. All right, so when I graph it out here, okay, so 0, 0 still. We're at minus 1 and positive 1 on the x and plus 4 and minus 4. So then we can draw our curvature on there. Okay. Now we'll look for the foci again. So c squared equals a squared minus b squared. So that's 16 minus 1. So that's 15 is c squared. So c is the square root of 15, which is about 3.9. So that point is right here and right here. Now let's look at the eccentricity. That is E C over A. Well, C was 3.9 and A is 4. So that number is super, super close to 1. It's actually, I think, 0.98. Okay? Which tells us that this is really oblong. Okay, for for this. Okay. All right. So find the standard form of the equation of an ellipse with foci at -3, 0, and 3, 0, and vertices at -4 and 4. So we're just going to start out with simply graphing these ordered pairs. Okay, I got 1, 2, 3. So there's a foci. 1, 2, 3. There's a foci. And I got a vertex at -4 and +4. And then we will kind of draw our temporary ellipse. Okay, so I need A, B, and C. Now looking at this, it tells me that vertices are here and here. Well, that tells me that the major axis is running with the x. So if the major axis is running with the x, I got x squared over a squared plus y squared over b squared equals 1. Okay, so that tells me that A is the distance from here to here, which is 4. B, I don't know. That's the distance from the center to the minor. And C is the distance from the center to the foci, which is 3. So drawing on here, if I want to know what is this distance, B, I got this distance here, which is 3, and this distance here, which is 4. I got that right triangle again. Okay. Well, using Pythagorean theorem, I know that b squared equals 4 squared minus 3 squared. So that's b squared equals 16 minus 9. So b squared is 7, and b is the square root of 7. Square root of 7. So I can just plug it in. Do I have a squared? Sure. X squared over a squared is 16 plus y squared over b squared is 7. Got that from right there, equals 1. And there's your standard equation. Remember, if I wanted a general equation, I'd get everything on one side and I would get rid of these fractions here. Okay. Let's go back real quick and talk about a concept that I mentioned just a little bit. Okay, we'll go back to this picture. Okay, so if I take the distance from here and map it to the ellipse, back to the other foci, okay, that gives me the outline of the ellipse. Well, I've got this extra portion right here. So if I take that, cut it off, and move it over here, I get that entire major axis. Okay, so no matter where you are, from foci to foci to the ellipse, you will have the addition of that major axis. And that kind of what creates the major axis. Okay, so here we've got an ellipse, but notice it is not centered at 0, 0. It's some ordered pair HK. Again, we've got minus h with the x and minus k with the y. A and B are still, what direction it's the major axis is going, and then you've got your definitions for your foci. It's super easy. Again, like the parabola, most of these will be intuitive once you kind of get going and look at your graph. All right, so I've got x minus 2 squared over 9 plus y plus 1 squared over 16 equals 1. Okay, so that tells me that this is going to be b. So b equals 3 on x, and a equals 4 in the y direction. Okay, so it's not on x and y, that's just, on the x direction. And notice it's not centered at 0, 0. It is actually centered at HK, which is 2, -1. Okay, so if I go 2, -1, so 1, 2, -1, there's my vertex, or my center, not my vertex. So if I go 3 in the x direction, I'm going to go 3 to the left here. I'm going to go 3 to the right here. And I'm going to go 4 in the y direction. So that's 1, 2, 3, 4. And 4 in the downward direction here. And I can connect the dots with kind of an oval. Now that is really, really ugly, sorry. But see, once I find the center and I find A and find B, I have found the whole thing. So I don't really need all those definitions on that sheet. I could still find, I could still find C, C squared equals A squared minus B squared. Okay. That would tell me, how far is it from the center to my foci? Well, A squared is 16 minus 9. 16 minus 9 is 7. So that's square root of 7. So that's basically the last problem that we had. Okay. So this is radical 7 from the center, not radical 5, radical 7 from the center. Okay. Not from the origin, so you got to add it to these numbers right here. Okay, so it would be what? 2 comma negative 1 plus radical 7. Okay. Or you would subtract it going this direction. Okay. Graph the ellipse given by the equations. Okay, now this one is in general form. Okay, this here is in general form. So we're going to have to get it into that user-friendly standard form. Okay, how am I going to go about doing it? Well, you notice I've got x's here and y's here. So I need to work with those. So what I want to do is I want to take this, and I've got a common denominator here and here. And I'm going to move this over to the other side. Okay, because we have to complete the square on these, because if you notice over here, I've got this factor, these two factors up here. Okay? So what I'm going to do is I'm going to take the 4 out, and I'll have x squared plus 6x plus blank plus 25 was brought out, y squared minus 2y plus blank equals 39. Now how do I know what goes in the blank? That is still b divided by 2 squared. So that's 6 divided by 2 is 3. 3 squared is 9. Here's the catch though. I don't add 9 onto this side, because I've got this 4 out here. So I'm going to take 4 times 9, which is 36, and I'm going to add that 36 over there. Okay. And here we're going to take negative 2 divided by 2, which is negative 1. Negative 1 squared is 1. So then I've got this 25 out here, so then I'm going to add 25 over here. Okay. So then I get 4 x plus 3 squared plus 25 y minus 1 squared equals, if you add all those up, you get 100. Now remember, over here, this has to be a 1, so we're just going to simply divide everything by 100. So then you get x plus 3 squared over 25 plus y minus 1 squared over 4 equals 1. So now I'm in the standard form. Here's my longer one right here. So I know that A is 25 on X, and here B is, or sorry, A is 5 on X and B is 2 on Y. And my center is at -3, 1. I got that from here and here. Remember, again, it's the opposite of them, of what they look like. So then we'll take this and just graph it. Okay, so we're at -3, 1. There's your center. Now in the X direction, we're going to go right 5. So 1, 2, 3, 4, 5. We're going to go left 5. So 1, 2, 3, 4, 5. Here. And we're going to go up 2. 1, 2. 1, 2. And we're going to go down 2. 1, 2. So here, got my bad drawing of my ellipse that was described in that equation. Now again, I can find where's my foci, what's my eccentricity of all this, but this is the main idea that we're going to want to look at. All right, so I got a little word problem here. So the longitudinal section that includes the 2 vertices and the center of an official Wilson NFL football is an ellipse. The longitudinal section is approximately 11 inches long and 7 inches wide. Write an equation governing the elliptical longitudinal section. So some big words here. So I've got this football here. Got this Wilson football here. Okay. The long side is 11. From here to here is 11. And from here to here is 7. Okay, so that is even on both sides. So that's what, 3.5, 3.5. This is 11, so 5.5, 5.5. So kind of like with our parabolas, if I put this at the origin, here, you just line this up with the origin. What is A? Well, A is 5.5. What is B? B is 3.5. It's longer in the X direction, so we'll say X squared over 5.5 squared plus Y squared over 3.5 squared equals 1. Okay, you can square those out if you want. No need to. That's just the simple, quick, easy way to get your equation for this. Now, ellipses are really, really easy. Okay? Some say they're easier than your parabolas. But here's your suggested problems. Work them out. And this is not 8.2. This is 8.3. It's 8.3. Work them out. Write down your questions. Bring them in. Let's work them out, and let's get understanding this stuff. Okay. Thanks for watching, and hope you understand this. Hope this video helps.